Welcome back to Who Wants to Be a Mathematician? I'm your host, Mr. Hill, and welcome to a very special, spooky, scary episode of AP Calculus. Yes, that is right. It's Halloween evening, and we're tossing it off with derivatives of an inverse function. So let's say that we wanted to find the derivative of an inverse, and all we're given is f of x. Well, we're going to need to find the inverse in order to find the derivative. Makes sense. But first, let's start off with our function f of x and its graph. So if we have our lovely set of axes, nice and straight, just how we like it, and we want to graph our function f of x, well, we can do it two ways. One is we can do the old school method of taking out our chart, plugging in some points like we did the -3, -2, -1, 0, and all that. Or we can think back to pre-calculus and when we had shifts of a graph. And we know that each number in our function does something to our graph. So if we have our f of x, then we know our parent graph is going to be x squared. That's what the shape is like. We know that looks like a parabola. Well, if we have a -1 being added to it, then we know that it's y shift. So we know we're going to shift down 1. And if we have a negative sign in front of our x, well, we know that just means that our parabola is down. It's all sad. So we know it's been shifted down 1 in the y direction and is now sad. So here we go. So this is what our f of x looks like. Now, if we want to find f inverse of x, we can either solve for the inverse and do all that craziness, or we can graph it. And we know some different properties of inverse functions. One is the inverse function is just a reflection over the y equals x line. So if you draw your y equals x line, then it's just a reflection over it. And how do we get that reflection? Well, one way is we take this point here. So this would be 0, -1. And we know that our f inverse has the opposite of that. And by opposite, I mean it is -1, 0. So if we plot that, if we go -1, 0, we know it's going to be like this. And we know that it's a reflection over our dotted line. So if we reflect it over, it's going to look something like this. Another way, if this is giving you some hard times visualizing, you can say, okay, this is about, I don't know, half an inch. So that means that my red graph is going to be half an inch opposite of it. This part is going to be, I don't know, 1/8 of an inch. So then this part is going to be 1/8 of an inch. So you can reflect it that way if that's how you want to do it. Or if you fold your piece of paper over the dotted line, then it's just all that. But that's craziness. So now we've graphed our function and its inverse. So a couple things we notice. One thing we notice is that the point, our function value, when 0, -1, or its vertex, is inverted of our inverse where it's opposite. So that's one thing we notice. Another thing is it reflects over our y equals x line. And a third thing, what do we know about slopes? Well, if we look at the slope at the dot, we have a slope of 0. This would be our slope. Let's change this a little bit. So we have a slope of 0. Well, if we look at the dot on our red line, this is a slope of undefined. Or you could think of it as 1 over 0. So slopes are inverses. So not only are our dots inverses of each other, but so are the slopes. So slopes are inverses. And by inverses, I mean reciprocals. Alright, so that's one. Let's clear the board. Let's move this craziness away. Let's bring in example 2. So now I want you guys to graph this function and sketch its inverse. So if you forget the pre-calc stuff, you can use a calculator. However, on the AP exam, may not be a good idea. So pause my video, go graph that in its inverse, and we'll be right back with it. So if you haven't paused yet, you probably should do that now. No, seriously, pause the video and go do it. Alright, so you should have done it by now. So if we are graphing this, woo, spooky music in the background, we know this number here moves it to the right. I had to think about that for a long second. Right 2. This number here moves it down. Oh, cat. Down 1. Had a little cat incident right there. And we know the parent graph of x cubed looks something like that. So now if we put all this together, then we are going to get the function. Whoop. So down 1. Oh, that's not what I wanted at all. That was the eraser, not the drawing tool. Here we go. So down 1, right 2. And we know that our function looks something like this. Now, if we want to graph its inverse, we draw a dotted line. And this point, 2, 1, now becomes 1, 2. So if we go 1, 2, 1, 2, our dot is now here. Oh, hey, let's back that up. This is a -1. Jeez, that looked a little weird. All right, so this is really -1, 2. So -1, 2. Here we go. That looks a little bit better. And now if we graph its inverse, it's going to look something like this. Something-ish like that. So there we go. Graph that in its inverse. You should have gotten something like that. So now, let's talk about slopes, shall we? Clear the board. Get this craziness out of here. Number 3. So show the slopes of the graphs f and f prime are reciprocals at the indicated points. Well, if we talk about our function, f of x is equal our square root of 2x, or 2x to the 1/2. And we're looking at 8, 4. And now if we have our f inverse of x, x squared over 2, how nice of them to do that work for you. So what do we want to find? We find slopes. And what is a slope? Another word for slope is a derivative. So we just find a derivative 1/2 of 2x to the -1/2. Don't forget to multiply by our insides. Then if we come down to f inverse, oh, this gets confusing. Let's do prime. Then we have 2x over 2, which is equal to x. So now what do we want to find? Show that they are reciprocals at the indicated point. So, at the point, we plug in our 4 here, and we get 4, so this turns into 4. And how about up here, we plug in our 8, well, 1/2 of 16 to the -1/2 times 2. This 2 and 1/2 can just go away, so now I have 1 over 16 square rooted, which equals 1 over 4. And how about that? These are in fact reciprocals of each other. Bada bing, bada boom, we're done, we're happy. Nice. So now, GP guided practice, it's your turn. So figure out how to do this, and then I'll be back with an example. So pause me, do the problem, and we'll come back. No, seriously, really pause me, do the problem, and then check your work. If you haven't done it by now, you should have paused me. Pause me, do the work, then come back. Pause me, do the work, and then come back. Alright, and we're back. So, what are we trying to find? We're trying to find slopes. How do we find slopes? That's another word for a derivative. So we take our derivative, and we get 3x squared. And how about our inverse? F inverse of x primed is our 1/3, x plus 2 to the negative 2/3. And now we're just going to simply plug in our 6 here, and this is going to be 1/3, 8 to the negative 2/3. And I know this looks like 1/3 times 8 to the 2/3. Oh man, 8 squared, cube rooted. It's going to be a number, and in fact it's going to be, if we plug in 2 here, we're going to get 2 squared, which equals 3 times 4, which equals 12. So I'm just going to go out on a limb and say this is 1/12. Hey, look at that. These are reciprocals. Done and done. So stay tuned. We're going to flip the page, but we're going to do another video. So take a break, and then we're going to come right back at it.